Hello Internet! Now at the end of 2021, there are a lot of new large language model emerging. You know that for artificial intelligence, the simulation of human behavior includes the human language, and we need LLMs for simulating the human interaction. A 10-second interrupt for you. If you want to find out a little bit more about LLMs, have a look at two videos I did. The first one is called After GPT-3, the New Queen. This is about the NVIDIA supercomputer model that is called Megatron LLMG 530B and how it is developed, on what dataset is trained. This is the PILE, the 800 gigabyte dataset. And the second video is how you implement this on a supercomputer. And this video is called Omniverse Avatar. And if you jump into this video, you will see that I show you here from NVIDIA itself how the supercomputer is constructed, what you need, how the software requirements look, how the tensor core GPUs, what the GPU memory requirements are. You get a detailed information about hardware and software and how to implement this on a supercomputer. This was it for the interrupt. Back to the original video. When two humans interact, they have a lot of information about each other and they can adapt their information accordingly. But what you want to do with artificial intelligence is, on the other side of you is not a human, on the other side is a cloud supercomputer. And this cloud supercomputer needs a model it can execute. So when you ask a question, the supercomputer is able to deduct an answer, construct an answer, given the training set, the training, and the new model this supercomputer configured. We look here at a news article from Google AI, from Google Research, posted December 9th, 2021, where they present the new large language model. And it is called the Generalist Language Model, GLAM. And for the first time that I know of, they passed a trillion weight model. So you have million, billion, and then you have trillion weights that you can modify in this large language model. And if you remember, I did on the second half of this year, 2021, I did a video on GPT-3, and it was just a 175 billion weight model. So within 1 year, we get from 175 billion to over a trillion weight model within 1 year. And you can imagine what it means for the next years to come. But let's have a look at this, because if you have such a beautiful model, you need data, input data to train your model. And Google says here, Google AI blog says here, that they have a high quality 1.6 trillion token dataset. You remember that given, if we use here some transformer model, that with transformers, for example, with bird transformers, in the simplest case, you have that the word consists of word pieces or word or tokens. So one word can consist of one to several tokens. So if you have 1.6 trillion tokens, you know that your dataset is quite huge. And last time I showed you that the PILE, the 800 gigabyte dataset, the PILE, which was GPT-3 and Megatron LLMG 530B trained on, now we have a dataset of 1.6 trillion token. So all of Wikipedia, quite a lot of all the books, maybe all of Twitter, this is just some billions, so no problem at all. If you want to have a look at it, there's a beautiful graphic that tells you how this system is working. They do some feed-forward network substitution with an expert layer, but this is not about this, what they say, why we do this, that they have a 1.2 trillion free parameter. So imagine you have, I don't know, a drawer with 1.2 trillion little baskets you can put information into. My goodness, I mean, what can you not store data in? But this is not just storing data, this is learning from those stored data a language model. So we have here the 175 billion parameter GPT-3 that you are familiar with, and now we have the 1.2 trillion parameter model and you see their performance in the task and whatever. I leave you the reference here. And here you have 3 people. Person number 1 loves alpha R, person number 2 is indifferent to the specific topic, and person number 3 do not love this. Well, you see, this is not just one sentence, because a sentence is always embedded in other sentences. And if you take now only these 3 people who disagree on one topic, but all of their sentences is fed into an LLM, and not only their sentences, also the subtitles or the translation of YouTube videos are fed into this real LLM dataset. So what you have now as an input data to your model that you want to train is, you have given 1.6 trillion word tokens in the training dataset. You can say that you have about 10 trillion sentences you train your machine on, maybe even 100 trillion sentences. And this is the input, and now begins the computing. And I suppose this is the biggest cloud compute Google has ever done on an LLM, because they are so proud that they have 1.2 trillion free weight parameter to be learned, to be trained, so that finally you have a model. And the situation is, you as a human ask a question, and Google Cloud and this trained LLM gives you an answer. But this is an answer with all sentences from all 3 people who have complete different ideas. So what about your data? Now easy. Imagine you are on a platform, let's say Google or Facebook. You're on another platform 2, let's say this is Instagram. And you're on platform 3, let's say, I don't know, Twitter. And there you post, you're informed, you have a chat, you write something. And all those information a machine can collect. Then I get all the sentences from your personal information of all those publicly on platforms where you post it freely, and I get all the sentences. Let's say these are all the sentences for myself. So the first task is, if I have, let's say, 10,000 sentences from my platforms, a very short interrupt for 10 seconds. If you want to know a little bit more about how do you program your own sentence embedding, it is very easy. I have here an own playlist created for you. So when you jump in, you have here 13 videos showing you here exactly the way how to code in PyTorch, in JupyterLab, your BERT transformer models, your sentence embedding, how you optimize your sentence embedding, how you download pre-trained model from Hugging Face from you, how you do the dimensionality reduction with UMap and DenseMap in JupyterLab. What about you have to care for cosine similarity? We go through asymmetric semantic search within the sentence transformer and graph theory to visualize this in 3 dimensions. So if you're interested in this, there is a whole playlist available for you. Here, code your own sentence transformers. And with this short information for you, back to the original video. What I do is in NLP, the standard, I have a transformer model so successful in 2020 and 2021, BERT. And I can do sentiment analysis, clustering, question answering, and even give a short summary. But now, even if I have now all my 10,000 sentences, if I have the metadata of the network, imagine what I can do. I can find out where I said it, which pictures I took, whose person are in this picture, with whom I interact in my world, and all of this leads to the question, can a system extract my personal behavioral characteristic, my values, my individual patterns? And if you're interested in applying graph neural network for yourself, if you want to see the code that I use, I have here a video playlist for you. It starts with my top 9 videos to understand and code graph neural network itself. You have here the model, the deep graph library. I have here the graph Sage, the graph BERT model. We have here on specific Google networks that are based on JAX, the Giraffe graph neural network. We have a theoretical video on representational learning on graph neural networks that gives you an understanding what symmetry means for you, how to create neural networks themselves, a general alternative to the PyTorch libraries and to PyGeometric libraries. So if you're interested in GNN, there are a lot of videos available for you. Have a look, play around, enjoy it, and maybe you can use it in your own work. Back to the original video. Can a machine really learn what it means to be me to give me a personal, individual answer? And the answer for that question is yes. Because you take all the sentences and you apply NER, entity recognition system, provided by Google, for example, and you create a knowledge graph. And now a graph is a much more complex interlinked system. And if you train this graph, this new data with a network structure in a graph neural net, then what you end up with is a new embedded graph. And this embedded graph is special in two ways, because the embedding in a lower dimensional Euclidean vector space means you have less complicated visualization and you can apply the analytical tools you have or mathematical tools you have for vector spaces. Proximity, close by, are essential to identify in a network groups. And on the right hand side you have two groups. Those are my friends that I go walking with, and the other group at the bottom of the screen is the group I go dancing with. And my communication with these groups is specific, has specific sentences. And if you want to find now the topics we talk about, you can apply normal graph theory and calculate the centralities. Or you can have the shortest graph, the shortest path on this graph, if you want to find my augmentation. Or to identify emotional triggers, use word to vec. But even more complicated tasks can be done, like link prediction. Let's say you have a network on the top right of the screen, and on the bottom you have a different network. And those orange water drops are nodes where I can link and I can connect these two networks. A graph neural network can do this. We need an LLM, and we can perform some beautiful algorithm on it with a BERT model in NLP. But much more interesting is to create a knowledge graph, to have the input data in a graph structure, so you can answer now the question, Siri, how can you answer? And the answer is, I have an LLM, I have a cloud supercomputer, and I have a lot of personal information about your specific characteristic and traits. Thank you.